In this video, we're going to talk about the properties of a parallelogram. But in order to do that, we need to talk about the definition of a parallelogram. So the definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now, quadrilateral, quad stands for four, and lateral sides, so four sides with both pairs of opposite sides parallel. So looking at the figure ABCD, or ABDC, which is a quadrilateral, in order for this to be a parallelogram, both pairs of opposite sides must be parallel. So side AC needs to be parallel to BD, which we can mark parallel using these arrows. But we have to have both pairs of opposite sides parallel, so side AB must be parallel to CD. Notice I used two arrows to show these sides are parallel. It's so that we don't get confused to think this is parallel to this side. It classifies which pairs go together. So we can write the notation for the definition of a parallelogram in this situation by saying segment AC is parallel to segment BD. Once again, I'm using the parallel symbol. And segment AB is parallel to CD. Now, a property, if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent, which in our figure means that AC is congruent to BD and CD is congruent to AB, which I'm marking my congruence with these tick marks. And I can use this notation for this statement that segment AC is congruent to segment BD and segment AB is congruent to segment CD. The final property of our parallelogram is that if a quadrilateral is a parallelogram, then the diagonals bisect each other. And by the diagonals, I'm talking about the segment formed by connecting the opposite corners. They're supposed to be a straight line, but when you do this without a straight edge, this is what happens. And so our diagonals are intersecting at what we'll call the point E. And this statement says that these diagonals bisect one another, which, as we know from the definition of a segment bisector, means that segment CE is congruent to segment EB, and that segment AE is congruent to segment ED, which we can write in our notation to say AE is congruent to ED and CE is congruent to EB, which by definition makes the point they intersect, E, the midpoint of segment AD and of segment CB. And we know this the reason we know this is by definition of a midpoint. Now, a special parallelogram is a rectangle. And if a parallelogram has one right angle excuse my typo, then it is a rectangle. So looking at the quadrilateral or parallelogram ABDC, if it has one right angle, that makes my entire quadrilateral a rectangle. And so using our notation, we can say that the angle CAB is a right angle. Our next property of a rectangle here is if a parallelogram is a rectangle, then its diagonals are congruent. Once again, my diagonals are the segments connecting my opposite angles. So given that this parallelogram is in fact a rectangle, then its diagonals are congruent. And we can write this in our notation by saying segment CB is congruent to segment AD.